Okay, so graph 3x plus 2. So 3x plus 2, your y-intercept is 2. So I'm going to plot this point right here. Plot my y-intercept first. And then my slope is 3. So from this point, I'm going to go up 3. 1, 2, 3 over 1. Okay. And then there's my line for the first line. Something like that. Okay. And then my second line, y equals 3x minus 2. So negative 2. That's my y-intercept because minus 2. And then I'm going to go up 3 over 1. Go up 3 on the elevator. And then it's the first door to the right. Okay. Okay. I should add arrows to these lines. Okay. When you draw your line, remember don't stop at the end point. Your line goes on forever, so just draw the line longer, extend your line, and then add arrows to it. Okay. What's similar between these two lines? Same slope. And if you recall, on Thursday, when they have the same slope, what does that imply graphically? They're parallel. So, okay. So remember that. If I say they're parallel, that means they have the same slope. If I say they're same slope, that means the two lines are parallel. Makes sense? Sounds good. Okay. This one. Let's try graphing this one. Okay. So x and y axis. For my first line right here, what's my y-intercept? Look carefully. -1, right? Yeah. That's why I keep asking you guys, because I know these are silly mistakes that you guys would make. So -1 is your y-intercept, and my slope is any? 3 over 3. So up 2 over 3. 1, 2, 3. Okay. Now, if the 2 points are too close to each other and you can't get very accurate, remember you can go up 2 over 3 or you can go down 2 and over 3 as well, because you know the direction of your line already. Okay, so this is my first line. And then here, y-intercept. 1, 2, 3, 4. So y-intercept means it's on the y-axis. And my slope? -3 over 2. So I'm going to go down 3. 1, 2, 3 over 2. Okay, again, if I want it to be more accurate, I can go down 3 again. 1, 2, 3 over 2. Okay, I can just do 1. I can do 2 points. I can do 5 points. Okay. Okay, what about these two lines? What do you notice about these two lines? They intersect, yeah, but more specifically, perpendicular, right? Now, perpendicular. Okay, can I just say that they look like they're perpendicular, or is there more support? What can I say? Or what can I see in the equation that tells me yes, they are? It's not just that they look like it, right? Yeah, negative reciprocal slope. Negative reciprocal slopes. Okay, we talked about this on Thursday. So this slope right here for the M, this slope was 2 over 3. And this slope right here was -3 over 2. Okay, so remember, it's not just negative, it's not just reciprocal, but both. So negative reciprocal. If it's positive, it becomes negative, and then 2/3 becomes 3/2. Okay. In the graph, what symbol do I need to add on it to show that they're perpendicular? They should. Yeah, the little square. Yeah. So, and yeah, that's right. Perpendicular means it means the same thing as 90 degrees. Okay. We will do angles in the last chapter. Right. So on the last assignment, some of you were saying how like the line rotated 45 degrees or rotated 10 degrees. We don't deal with degrees yet until the last chapter. So for now, the only thing that we do is the 90 degrees, which is because it's perpendicular. Okay, so that was a quick little recap. So if I give you a line now, y equals 3x plus 5, can you give me one example of a line that's parallel to this? Cindy?
3x plus 7.
3x plus 7. I like that. But you'll only get half a mark for this. Why? Y equal. Yes. Okay, so it's not an equation unless I see an equal sign. So y equals 3x plus 7. Because as long as the slope is the same, it means it's parallel. Okay? What about an example of a line that's perpendicular to y equals 3x plus 5? Oh. Oh. Y equal? Okay, so this slope right here is 3. And remember we said if it's perpendicular, it has to be negative reciprocal. So what's the negative reciprocal of 3? Okay, so Petro said negative 3. Negative 1 over 3. Not just negative, but also reciprocal. Right? So negative 1 over 3x. Plus what? 5. Okay, Mohini says 5. I say 10. Annie says 0. All right. For perpendicular, can you have the same y-intercept? For perpendicular lines, can you have the same y-intercept? Who says yes? Yeah, you can. Good. But what about for parallel? Can parallel lines have the same y-intercept? No, because if it's the same, it's the same. Okay, so it's not another equation. So that's a little trick as well. Parallel lines, you cannot have the same y-intercept. Perpendicular lines, you can have the same y-intercept. Okay. Example 2. Write the equation of a line that's parallel to this and passes through this. Oh, this sounds very similar to the questions that we were doing on Friday. Okay. On Friday, we talked about the 2 things you need to make your equation. What are the 2 things you need to make any equation? Y-intercept? And? Yeah. So are we given, and so on Friday, we were given both for 1 so that we could come up with the equation. What about right here? What are we given? We are given the slope because it says it's parallel. So parallel means I'm given the slope, which is 3. So it's just a different way of telling you the question. Okay, given a slope, given a point, so now I just need to find B. Okay, which is exactly like what we were doing on Friday. This is my x value, this is my y value, this is my m value. So let's sub it in. So y is negative 6, m is 3, x is negative 2, and then plus b. Right? Parallel to this means that m is 3. And then you have that. Okay. So negative 6 equals negative 6 plus b. So what is b? 0. Yeah. So what's my equation? Y equal, so 3x plus 0. If you write this for me on the test, you're going to get half a mark off. Alright, it's not wrong, but format is not good. So as Petro said, you should just leave it as y equals 3x. Okay? If it's plus 0, we don't need it. Right? Any question on number 2? Okay. 5. Alright, so you see it ties into, you see how this ties into everything we did on Thursday and Friday? Okay, so similarly, write the equation of a line that is perpendicular to this and with the same y-intercept. Brendan. Or okay, so first up, what is my slope right here? Is my slope 3? Okay, who says my slope is 3? Because it's 3x, so my slope is 3. Okay, why not? Yeah, it's not in slope form. This is in standard form. So that means we have to rearrange this. Before we can do anything, we have to rearrange this first. Okay, into y equals mx plus b form. So I need to move this over, and I need to move this over. Right? You can see the format. It's not the same. Y equals mx plus b, and standard form. So that's why we have to move it first. So negative 5y equals negative 3x minus 40. That's when we move it over, we have to change the sign. What am I going to do with this negative 5 now? Any? Divide it. Yeah, good. Divide each of the terms by negative 5. So y equal, what does this simplify to? Negative 3, negative 5, but 2 negatives make a, so 3 over 5. Good. And then here, plus 8. Okay, a lot of people will say, okay, 40 divided by 5 is 8. And then they write the 8, and then there is like no sign in between. So make sure, alright, you write it like that. So now that we have this, it tells me that my m is 3 over 5, and my b is 8. Alright, now I don't want this equation. That's good. You did half the question, but I wanted you to write another equation. Write the equation of a line that is perpendicular to this. So perpendicular to this means my slope is going to be. So what is it? 5 over 3, negative 5 over 3. Yeah. Remember, I keep saying, not just negative, not just reciprocal, but negative reciprocal, both. So negative 5 over 3. Okay, because perpendicular. So negative 5 over 3. Same y-intercept. Same y-intercept. So it means my b is same, 8. Okay, so what's my new equation then? Perfect. Good job. so this is a multi-step question. If you see this question on the test, can you follow along and do all 3 steps? If you see this question on the test, do you think you can do it? Okay. I hope it does. Okay, good. Okay. Write the equation of a line that is parallel to the x-axis and passes through the point this. Okay. Whenever you see questions like this, parallel to the x-axis, perpendicular to the y-axis, any parallel perpendicular to x and y-axis, the easiest way to do these ones is to do a quick sketch. Okay, easiest way to do these questions, do a quick little sketch. Okay. So quick sketch means it doesn't have to be accurate. Let me just do this, x, y, passes through the point 2, 5. So 2, oh, I should have lowered it, sorry. I don't have whiteout. Anyone have whiteout? Thank you. Thank you. Sorry. Thank you. Okay. I'm just lowering my x-axis because I want to be able to show you guys the thing. So sorry if you drew. I hope you guys didn't use pen. I'm only using pen because it's easier for you guys to see on the screen. I would always do math in pencil. Alright, so passes through the point 2, 5. So 2, 5. 1, 2, 3, 4, 5. So this point right here is 2, 5. Okay, that's why I had to lower my line. Let me just. I'm just drawing the grid back in. Alright. Now I want a line that's parallel to the x-axis. Does it mean I'm drawing a horizontal line or vertical line? Horizontal. So if I want a horizontal line and it has to be parallel and it has to go through this point, that means my only option is this right here. Right? Does that make sense? So now this line is parallel to the x-axis, yeah, and it passes through this point. So in any horizontal line, what's the equation for any horizontal line? X equal, y equal, y equal 5. That's it. Okay, so that's why I said with these questions, the easiest way is to draw a quick little sketch. No calculations involved, because sometimes with in the next one, for example, you'll see that the math doesn't even work out. Because this point right here is 2, 5, right? 2 and 5. So a horizontal line always has the form y equal. And what's the y value right here? 5. Okay. So this is 2, this is 5. Right? The point 2, 5. So any horizontal line, it means that every single point has the y value of 5. So it's y equals 5. Okay. So similarly, write the equation of a line perpendicular to the x-axis that passes through the point -4, -5. Okay, so -4, -5. This time I'm going to put my x-axis a little higher because I know where my point is. So x-axis, y-axis. I'm going to plot this point, -4, -5. So -4, 1, 2, 3, 4. -5, 1, 2, 3, 4, 5. All right, so this is -4, -5. Okay. I want a line that is perpendicular to the x-axis. So perpendicular to it, meaning is my line horizontal or vertical? Right, because perpendicular to it means it's vertical. So I know my line looks like this. Tell me when I should stop. Right, okay? Because how do you know it has to be right here? Because it has to go through this point. So the only vertical line that goes through that point is like right here. Okay? So if a horizontal line has the form y equal, what does a vertical line have the form of? Pedro? X equal. Yeah. And what is that x value? Negative 4. Right? Okay. Every single point on this line has the x value of -4. And by the way, what's my slope here for a vertical line? Undefined, right? So if you try to do this solving the y equals mx plus b method, it's not going to work because your slope is undefined. So mathematically, it won't even work. What's my slope for a horizontal line? 0. Right? Alright, so these ones, it does take a little bit more practice, okay? Because you're not used to seeing a question that gives you like so little information. So you do have to try it out on your own, make sure that you understand it, okay? There are a couple of homework questions on these, so make sure you do them. Okay, last example. Given these 3 points, show mathematically whether the points form a right triangle. Okay, right triangle. So let's draw a quick little sketch first. Just a rough sketch. Negative Annie? Thank you. -4, 7. So -4, 7 up here. This is point A. -8 and 0. So about like right here. This is point B. And then 6.5 and 1. 6.5 and 1. Alright, so this is point C. Okay. What am I doing with these 3 points? What am I drawing? Am I drawing a square? Am I drawing a star? Or circle? What am I trying to draw? Right triangle. So, yeah. Yeah. Trust me, I've seen people draw me this. Even though the question says right triangle, you don't want to know. Okay, so connected the 3 dots, made a triangle. Now looking why I did the sketch, notice the question never asked me for a sketch, but doing a quick sketch, looking at it, which angle do you think looks most likely like a right angle Angle A. So you want to figure out if this is 90 degrees. Now, we don't use protractors anymore. If you have one, you can throw it away. We don't use it anymore. Even in the angles unit, we don't use protractors anymore. Because that's like grade 7 stuff. Yeah. Okay. So, using our grade 9 knowledge, how can we figure out if this is 90 degree or not? Sean? Yeah, I have to find the slope of AB. I have to find the slope of AC and compare it. Let's do that. Slope of AB. Okay. How do I calculate it? I'm given 2 points. Easiest way to calculate slope is y2 minus y1. Well, you did tell me only half the equation. Right. Okay. I'm going to call this x1, y1, x2, y2. So subbing it in, this y2 is 0, minus y1 is 7, x2 is negative 8, x1 negative 4. Okay, notice I put brackets around every substitution. Okay, you want to try to do that too, so that you can see the double negatives. Numerator 0 minus 7 is negative 7. Denominator negative 8 minus negative 3. So what is this simplifies to? Negative 4. Good. Huh? Okay. Okay, negative 7 over negative 4. Is that good enough? Both negatives cancel out, so it's 7 over 4. Okay, so we did the first part. We did AB. Okay, as Sean said, now we have to do the slope of AC. Okay, and get used to writing it with subscripts, because in when you get into grade 12, you're gonna do like slopes and things for like 10 different lines. So in order to know which line you're talking about, it's a good habit to start now to write the subscripts. Okay, so same formula. Now I'm gonna call this my x1, xy2, x1, y1, x2, y2. Remember, order doesn't matter as long as you're consistent. So y2, 0, y1, 1, x2, negative 8. Oh, yeah, why am I doing B? I don't know. Good question. So x. Thank you. Sorry. That's 1. So 7. It should be 7. 7 minus 1 and negative 4 minus 6.5. Okay. Again, if you did this as x1, y1, x2, y2, you'll get the same answer. Order doesn't matter. Alright, so 7 minus 1, 6. Negative 4 minus negative 6.5, you get negative 10.5. Okay. Why did I use decimals? Okay. What's the easiest way to tell you guys to change this? Okay, I could double it so that I don't get that negative. If I double this fraction, I'm gonna get 12 over negative 21. Okay. Or I can, yeah. Right. So this is a bad example because I used decimals in my coordinate. So that's why I changed it to this by doubling both the numerator and denominator. to get rid of the decimal. But this, can I reduce this? Yeah, 3 goes into both 12 and 21. So 12 divided by 3 is 4 and -7. Now when I compare it, what do you notice? Why? Because they are negative reciprocal slopes. Which mean that therefore they are perpendicular, which means this is a right triangle. Let me zoom this out a little. Okay. If I didn't do this little sketch right here, you wouldn't know which angle you were trying to look for. Alright, that's why doing a quick little sketch, then it's pretty obvious. Okay, I should probably check angle A. So that means I should do the slope of AB, slope of AC. If I didn't do the sketch, and I did slope of AB with slope of BC, of course they're not going to be different. Of course they're not going to be the same, and there's like no connection between the slope of those two lines. Okay. Any question on this example? Okay. So today's lesson, it's understandable, but it is tricky. So you do need to make sure you practice all of these questions. It's not a lot. 1, 3, 6 to 10, and 11. Try it out now. You have half an hour. If you have any questions, feel free to come on up to ask. Okay? You have half an hour to start on this, and then anything not done will be homework. I will do homework check tomorrow. Yes, because as I said, these are like really different kinds of questions. So you do need to practice. Alright, so try these.